Okay. Thank you very much to be here. As I have explained before, thank you to the heroes of coronavirus. We're going to start. We yesterday were preparing the panel, and I have to say that we have a really good standard here today. We have a significant. Supposedly, we are going to have a significant discussion because the people that is in the panel is really high prepared people, and they have a lot of experience on what we are going to talk. We're going to talk about digital transformation. We are going to talk about the change of mindset in the companies of the digital transformation that you all know that is necessary. We're going to talk about what the hell is deep tech, because we have heard about it, but most of the time we don't know what it is, and the panelists know in a good way what it is, and they are going to explain some cases of use, and I think that it's going to be interesting. And we are going to connect with smart cities and with energy solutions. So I think that is going to be an interesting panel, and we start to present the different panelists. Okay, the first. Firstly, we are going to start with John. John is the water industry and strategy leader for IBM Energy, Environment and Utilities business in the UK. Much of his recent work has been in creating the smart utility, applying digital technology and analytic intelligence to drive systemic end-to-end transformation. His current focus is on sustainable the transition to net zero and resilience in the face of climate change. John is a regular public speaker and author on energy and environment issues, innovation and business transformation. Previously, John was the IBM lead client partner for a global oil major. For over 30 years, he has consulted in a wide range of industries worldwide, having started his career with Pricewaterhouse after studying economics and mathematics at university. It's an amazing bio, so let's start with John, and after some introduction of the different speakers, we will start the questions and the conversation. Thank you very much.
I'm a Wex newbie, actually, so I'm really pleased to be here for the first time. Have to confess, I didn't know the term deep tech, and as an IBMer, I don't always say this, but Google was my friend. I looked it up, and it turns out that we do a lot of deep tech, and I just want to talk a little bit about what we do in the water industry. So our researchers work on problems across all of the industries that we work in, and in all the countries that we work in. And that ranges from drought in Africa to finding solutions to new diseases. And to do that, they combine knowledge from different scientific disciplines across quite a wide range of technologies. And that might be material science, it might be physics, data science, weather forecasting, electricity networks, or behavioral economics. And some of the programs that we're involved in take years or decades. And the work that we've been doing in revolutionizing batteries would be an example. And others come to fruition in months. So we've got over 3,000 researchers in 12 major labs. And in 2019, we, for the 27th consecutive year, were awarded more patents in the United States than any other company. More than 8,400 IBMers in 54 countries contributed to 9,262 different patents, working across blockchain, quantum computing, and different types of membranes. And because they work on problems, and those are the most important, most complex problems that we face, they invent useful things, and this is how they describe themselves. We invent things that matter for the world. So I just wanted to talk about a couple of examples, and then I'll leave you with a bit of a challenge. So imagine if we could recycle all the PET plastic into a reusable feedstock that we could make high quality plastic for. So the researchers have come up with a biological catalytic process that does just that. Imagine if we could test soil and water for chemical presence on the spot. Anybody could do it. So the AgroPad has micro embedded sensors, uses a smartphone, AI in the cloud, and allows anybody with no scientific training to test water or soil anywhere in the world. Imagine if batteries could charge as fast as filling a car, store as much energy as we could in a conventional fuel tank. We didn't need to mine for heavy metals to make the cathodes, and they cost less than conventional technologies. This is the work that we're doing with Daimler-Benz, using quantum computing to investigate new materials. And recently we announced a breakthrough in the cathode material for lithium sulfur batteries that doesn't require cobalt and which has a higher energy density than the best lithium-ion batteries that are currently being used. And what about if we could chemically fingerprint the water anywhere in our network without having to take a sample to the lab, and we could do that in the stream? So this is what the electronic tongue does, using electronic sensors and neuromorphic computing to taste the liquid in much the same way that our tongue tastes food. And what next? So we're working on a computer that will be 1 millimeter square. You think about what that means for edge computing in the Internet of Things. I mentioned brain-inspired neuromorphic systems. These are systems that work in a way that's more analogous, not the same, but more analogous to the way the brain works, and particularly useful for large-scale neural network problems. And then, of course, there's quantum computing, which in an industry like ours has an application in the large-scale, real-time optimization and simulation. So we saw digital twins yesterday, but if you imagine a digital twin of the entire ecosystem in which we work, the ability to simulate actions in real time, that's the promise. But here's the challenge. I think the question is not what's next. In fact, it would be what's now, if I could move the slide. But could you advance the slide for me? There we go. So my challenge really is that the technologies that we can deploy for business transformation in this industry, in the energy industry and in the adjacent industries like transportation, by and large exist. I'm sure there's going to be new developments, but the challenge here is to deploy the technologies that are available and are deployable now, not to think about research and development projects that could take 15 years. I think I've used my 4 minutes, so yeah. I'll hand over. Thank you.
Okay, thank you, John. Let's go with Dragan. Dragan is CEO at KWR Water Research Institute in the Netherlands and professor of hydroinformatics at University of Exeter in the UK. He has been at the forefront of development and application of hydroinformatics or smart and digital water for over 30 years. He has authored over 400 referred journal and conference papers and 24 books, chapters, and delivered talks on the subject worldwide. So, Dragan, thank you very much to be here.
Thank you, Jaime. Good morning, everybody. I'm not going to use PowerPoint, and I will try to raise few issues in terms of digitalization and water. First of all, let me say that digitalization for me is the big integrator of silos in the water industry. 25 years ago, 30 years ago, when I started working in the UK and with the UK water industry, they had department for leakage, for energy management, for wastewater management, for asset management. All of them collected data, and there was no way of connecting the data from those different silos. So for me, digitalization is the way forward, is that horizontal kind of connector between different silos. And I can tell you, for the research organization that I lead in the Netherlands, we have our clients and our shareholders are all the drinking water companies in the Netherlands and one from Belgium. So we don't have a team that is hydroinformatics team or digital water team, because that is the one that percolates, again, all the activities, groundwater, water resources, distribution, asset management, all of those are connected. So that was, I think, my first thought about digitalization as an integrator. And I really like what was said this morning about systems approach. We're looking everything in an integrity rather than, you know, individual elements of our systems. So that's one. The other one, it may be a bit controversial, but let me talk about hype cycle. I don't know if you've seen the curve where everybody expects that everything will be solved. In this case, I'm not talking about digitalization, I'm talking about AI, artificial intelligence. Everybody is going to use artificial intelligence and solve all our problems in the world, particularly in the water sector. I'm worried that we are going to get to that disillusionment kind of trough afterwards, after all this excitement, because of various reasons. Don't forget how we use artificial intelligence these days in the water sector, in most sectors, to be honest, apart from Google robotics and stuff. We use it to do time series predictions. That's where the most applications in the water sector are. So I firmly believe in developments in robotics, in digital twinning, and other applications. But please, please, let's not inflate the potential of artificial intelligence. It can do quite a lot for us, but not solve all our problems. And if I can also finish with another thought, is that you've seen Teslas. They have their autopilot, and it works 99% of the time, or maybe 0.9. Well, there's still problems with it, isn't it? You know, when you fly on airplanes, and I came here yesterday to Valencia, I flew on an airplane. I'm sure that pilots use autopilot for part of the flight, so we believe in those. So my question for you is, why don't we have autonomous water systems? Can we have that? So for the end, let's kind of look, where is the future, and can we get to the point where our systems are semi-autonomous? I don't want to lose the human in the loop, because we can't be Teslas, we can't be autopilot. Mind you, even for that airplane, there is a human that is controlling the machine. That's all from me for now. Thank you very much.
Thank you very much, Dragan, and thank you for your comments. I agree with silos, with the problem with the silos in water community. Almost every utilities have this kind of problem, and it's almost impossible to deploy over different data solutions and so on. So, okay. Let's go with Miquel. Miquel has been working at SAP for more than 20 years in different roles, always related with the delivery of application and technology solutions for water and energy supply companies' needs. Currently is the Chief Solution Expert at the Utilities Industry Business Unit, contributing to the design of SAP technology and product solution strategy for water and wastewater companies, while keeping focus into enabling expertise in SAP solution portfolio among its ecosystem and explore knowledge and new opportunities around the water and wastewater value chain on global basis. Thank you, Miquel.
Oh, yeah, okay. So thanks very much for your time, and personal thanks to Wex for the invitation to join this impressive event, despite the challenges. And that says very much about you. My name is Miquel. I'm working at SAP. I think most of you know what is this company about. This company just makes applications and technology, period. Does not do any other thing, but that's its value because it's the expertise on building constantly and improving technology and applications for its customers. Translated into my job, my position is what we call product management. This is to understand what are the needs of a specific group of companies. In this case, the water sector. We focus into the whole water value chain, try to understand which are the present and future needs, and then we try to excellent in technology and applications for those requirements. I'll put as an introductory some areas where we are focusing in this understanding. From our perspective, there are 4 fundamental areas from the strategy point of view that application and technology providers like us, we need to focus in order to please companies like yours. The first one is digitalization. This is what you are manifesting and saying in this event. Digitalization has a clear impact in providing IT solutions, as this is mentioned in this report from the United Nations. What does it mean, digitalization? It has been said, I think a key word, this is the capability to provide a platform where there is a lot of information, in fact, all the information available to take decisions. So it's not only reporting, but it's shifting into a concept called interoperability, that you take decisions that are executed. For example, we partner with a company called Thames Water. This is not London, but all the Thames River area. And they had a major compelling event, which is the flows that occur in the country some years ago. So they needed a centralized area where we can constantly monitor and take decisions. And this is a kind of prototype you see in the picture with the big screens that they are synchronized, and then you can navigate through touching and take decisions in 3 dimensions. One is the supply flow, leakages, what is occurring. The other one is the customer end-to-end processes, complaints, any area where there are customers and there are incidents with them that are relevant and they can connect things, one thing with the other. And the other one is waterworks, what is going on in projects, construction, and works around. And then they can connect all these 3 things and take decisions: supply, customers, and activities with infrastructure. That's a complex architecture and leads to the concept of platform and big data. Another dimension we also recognize as relevant is what was called here the circular economy. I'm not going to elaborate on that, but we identify, in order to make feasible and achievable a circular economy output, a methodology called Resolve. That was already highlighted by McKinsey, and we think it's a group of elements that taken individually or collectively can illustrate projects related with circular economy outputs. And taking this methodology, we already work with companies. In this case, the Water Electricity Corporation, Water Corporation from Botswana. And we try to apply those elements systematically since many years, and that's what you see on purpose, 2014, in order to make a huge transformation where IT is enabling them to achieve sustainability goals. And that's a snapshot you can see below of an app, the propaganda or advertisement of a citizen app for this water company. And they said that all the functionalities that this application holds were according the sustainability goals of the United Nations. So everything is bundled, and it has a sense and a purpose. The third example is the scarcity of water. This is a fundamental issue. I think it has been highlighted recently by this lady that keynote us very precisely what is affecting in our territories. This picture is much more dramatic. This is what happened in Cape Town a few years ago, and probably it will recur again. And that means that it needs to be a very, very much supportive process to rationalize the consumption, because it's a scarce resource. It has to be rationalized proactively. Water companies is not the business of selling more water. It's to facilitate the water supply in quality, but also they have a mandatory mission to proactively activate programs of water efficiency, whatever it means. And we have an example with DIWA, the Department of Water and Electricity of Dubai, where they implemented smart meters, not only for the electricity part, but also for the water. That enables them not only detect leakages and other deficiencies in the infrastructure, but also proactively run what we call demand generation programs. This is to really conscience people and penalize whoever goes beyond the rational consumption. Because this is an area where water is already a concern, systematically. It's more expensive than oil, let's say like this. A fourth and the last item that we also address is the difference among what is in the surface, which is the water, but what is below under that surface, which are the pipes and infrastructure. This is an aging element that you cannot monitor sometimes visually because they are underground, so you need to figure out what are the conditions of those elements. And you need to manage its reliability. And that leads a lot of capital effort, because this is money. And you need to smartly move around the money with regulators to manage the CapEx, but also to drive what we call here artificial intelligence programs to understand or to figure out where is the corrosion of several segments of the pipelines, depending on the soil conditions, for example. This is complex calculations and has payback. So that's an area where we work in the field, but not only with that one, but also with the field workers. So we need to help field workers to be totally autonomous and have enough information to work and operate on the field. So there is a new generation of mobile apps that not only transfer electronically a document which is called a work order, but contains even information about the different layers of the territory where you have to dig to secure that you are not breaking telecom cable or things like that. And I think I burned out my time. So these are the 4 examples. And yeah, digital transformation is a challenge for many organizations, but within it deserves. Thank you very much.
Thank you, Miquel. Just about the lack of infrastructure, the lack of water. Yesterday, talking with Cecil from New York, he was telling that maybe the problem is not lack of water in some places. The problem is lack of infrastructures to manage in a right way the water, because we need to make investment that we are not, or planning that we are not doing. Just a reflection. Okay, so thank you very much for your words. Next is Dr. Guillem. Dr. Guillem Gilbert Oriol holds a master's degree in chemical engineering and processes for the Rovira i Virgili University. He started working as R&D scientist for the Dow Chemical Company at Global Water Technology Center in Tarragona, Spain. He got a PhD on ultrafiltration and started leading the reverse osmosis anti-fouling team. He is currently the research and development technical leader for the seawater municipal drinking water desalination market at DuPont Water Solutions. He is also assistant professor at Rovira i Virgili University in Tarragona, Spain. Thank you. Yeah.
Thank you, Jaime, for this nice introduction. I would like also to take the opportunity to thank the Wex organization for this nice event, and also Acciona for inviting us. So today I will tell you a story about how deep tech has entered into our DNA. It's been part of us, we've believed in it, and we've invested in it. So let me introduce you the Tarragona Global Water Technology Center. That's a facility. Not sure if you know about it, but I strongly recommend you to visit us. You have our invitation. And that's a facility that we inaugurated in June 2011. And that's unique water technology center in the world. It's got really industrial scale assets, but we wanted to design it so that we could go from very fundamental understanding, like some kind of the lab work and research that you will do at the university, partnering also with the university, and we can slowly scale up until we have our fundamental hypothesis confirmed. But we didn't want to stay forever with fundamental hypothesis testing, right, and fundamental learning. And I think that's could be like a trap that we should avoid in deep tech. So that's why we built this center with 3 real different water sources. I will comment briefly in the next slide, and treating all our core technologies. So we decided to build this center in Tarragona, not because we like Tarragona, I like it a lot because I'm from there, but nevertheless, the point is that in Tarragona we have access through 3 real water types, one being river water, the other Mediterranean seawater, and also access to the local wastewater treatment plant. We can research our main technologies, which is ultrafiltration, reverse osmosis and nanofiltration, and ion exchange resins, and lately bioreactors. And we support all the markets available, right? So from municipal to industrial, residential, pharmaceutical, oil and gas, and mining. So what I was mentioning you to in the beginning, right? In the past, we had troubles because someone had an idea, wanted to launch something, and maybe fast without doing this fundamental understanding that you need for deep tech, for really understanding your technology. And that's why we decided to build this center. We can get these real water types, and we can test our hypotheses starting with very fundamental research. I put a picture here of a biofouling simulator. That's a very useful tool, because if you have like 10 of those, you can quickly screen your hypothesis, see which way seems the appropriate for your success and validating your hypothesis, and then you can scale up. You can scale these to flat cells, like you have here. They are a small one. You can also test in batch. And then maybe if your hypothesis is confirmed, you can go and build a small home drinking element, right? Which it needs more resources, but it's like the next step from the fundamental research to almost having a commercial product. And when you start to see success, you can test in industrial scale elements, either a 4-inch spiral bound or an 8-inch spiral bound. In the wastewater platform that we have, we can have here ultrafiltration, reverse osmosis, and also in the industrial platform and the seawater and oil field platform. So to sum up, we have in Tarragona 40 different testing equipment. We can set it up at 150 different positions. This means we can test them in series or in parallels, or some in series and other in parallels. So that's very good for doing this fundamental research that you need in deep tech, and that at the end, it enables to have a successful product launch with a strong science behind. So I will not go into details, but one good thing of our center is that we are not just doing this fundamental research and application development testing, but we also support our customers. So our philosophy is building a network between university brings you talent, brings you fresh ideas, research, fundamental one. Customers is why you exist, right? They have problems, you need to solve them, but you want to solve them with deep science, deep tech. So in our center, we study the problems that our customers have. Here you can see different units, even what we call membrane autopsies, that's like medical almost. And what's been the outcome? So the outcome of these roots that we have on deep tech, on fundamental science understanding, but not limited to that, right? We want to be fast and an accelerator of innovation. We've launched 11 new products since 2011. That's significant. They are already in the market, and most of them you've heard them about. We've been able to reduce the cost of water by 15 to 25%, and reduce also the energy required for ultrafiltration. We've quantified what's been the impact, right? The impact for us is being able to accelerate product launch 10 times faster than what we did in the past before our center exists on 2011. And we've been also able to enhance our R&D pipeline with more or less around 50 R&D projects per year. Some are very fundamental, others are more customer-oriented, but that's the average. And we've been engaging 30 external cooperations and receiving 8 million in public funds. At the end, we've collaborated with 150 customers per year, and we've held more than 2,500 visitors. So just not to go any longer, please come to visit us and let's discuss any deep tech question or problematic that we could help you solving. Thank you very much.
Okay, sorry. Okay, so thank you very much, Guillem. Yeah, thank you. Let's start the panel. Let's start the questions for the panelists. Thank you. It's nice to see the university collaboration that you have and what, the solutions that you have presented. Okay, today we are going to talk about digital transformation. We are going to talk about deep tech, as we have told. And we are going to talk about the connection with the smart cities and the connection with energy. So let's start with digital transformation. That we are supposed to all the companies that is mandatory for us to do it. So to start, I would like to ask two questions. The first question is how should we do how should we fund the digital transformation? Because we know that we have to do it, but not every company have the budget to do that. And could we help to places where we don't have good infrastructures with digital transformations to improve their numbers and to get the efficiency for that? Let's just start with John, please.
So it strikes me that there's a difference between the type of technology that Guillem was talking about, which is kind of the fundamental process technologies, and the digital technologies that Jaime is referring to. And my observation of this industry is that we actually don't find it difficult to fund large asset-based projects. And we don't find it difficult to fund R&D projects, but we do find it difficult to fund operational deployment of digital technologies. And my kind of thinking here is that actually there's a bit of a mindset shift needed. So I'll spare the name of the company, but we did a project to investigate what was happening deep into a dark network, one that's very poorly instrumented. £250,000 of digital work, if you like, quite an expensive project in the world of agile digital. £46 million of benefit, and yet the question is asked: why are we spending that much money on IT? Why are we spending that much money on data analytics? Just down the road, there's a huge new waste-to-energy plant being built. Dwarfs the expenditure. So my thought on funding is actually, if you choose the right projects, these projects fund themselves. If you take the same mentality that you do for capital projects and apply that to projects that are they're capital projects in the sense that you're investing in digital, but they're actually changing operations. And you focus on the big projects that people care about, that have the big values, we don't have a problem funding the industry. That's my view.
Okay. Dragan, I would like to, could you, which is in some places where they don't have infrastructures or they don't have good service water, could digital transformation help them? Could they monitor some of their parameters, and could we improve their efficiency with this kind of investment?
Absolutely. First of all, there are physical infrastructure and this cyber, as they call it, cyber infrastructure, sensors, measurement devices, communication devices, and platforms. And there are examples in the world where this technology replaces what we do in the developed world. You know, when everything is piped, everything is pumped, everything is kind of controlled. And one of those examples are these water kiosks, water ATMs, where somebody has reverse osmosis that is using solar power to treat water, give people up to 20 liters of water per one kind of usage, and they're paying with their mobile phones. And this kiosk is connected to the cloud, so somebody can look at how much water is being used, whether it requires maintenance. Just a very simple example where the technology being used in less developed countries is kind of leapfrogging what we did in the West. So that's just very, very simple example. But I would go back to this question, do you have to have a physical kind of infrastructure? And people talk about, again, cyber being smart. But I think your physical infrastructure has to be smart as well. If it's designed in a way that doesn't fit nicely with the cyber infrastructure, you have to do something with the physical as well. I don't believe that you can, again, solve everything with digitalization, although that is one of the key kind of components of that smart system. And that's why systems approach, when, again, I'm coming back to that, physical and cyber have to work well together.
Finally, it's about joining OT with IT. That all of us agree probably that is the only way to do the things in a water company and probably in other companies. Okay, so for Miquel, when we join OT with IT in the companies, what we are making is a change of mindset of the company. When we make a digital transformation, we need a change of mindset in the company. How we approach this kind of change of mindset in the experience that you have in the companies where you have worked?
Yeah, for us, providing... okay. For us, providing IT technology and applications is our business. So we don't deny. If there is a possibility, we facilitate. Now, what we see is that this is not homogeneous. There is in this sector still the trend of replacing systems. They have the budget. They want to run an IT project because their already infrastructure systems are outdated. So they run the budget. They want to have the same, but with nice screens, let's say like this. No? And it's a human factor because the company has this trend. And we respect that, and because we cannot asphalt them. We just do business and we try to facilitate things. But we feel sorrow because we think that this is not anymore what the world needs, beyond the words, but they had the budget. What can you do? No? In those companies that they step forward, that changes dramatically because the mentality is not any longer to have a single project, change the system, and you forget about 10 years, 15 years if you're lucky, and then you have to have this pain again. No? Digital transformation enters into like a cycling that you are always moving, spinning the wheel. slower or faster, that's different. Because the key word for us, from IT perspective and technology, is what this gentleman said, is what we call the digital twin. You are remotely managing an infrastructure, so you need to have constant updates to simulate that reality in your screens. You need to see the water flow, the supply, in all the senses. You need to understand the health condition of your infrastructure, of your assets, and you need to know real time what is going on with your customers, industrial or residentials. This is the digital twin. That's a paradigm, and you cannot achieve this in a single step project and forget about them 10 years. That's not the way. So when we face companies that they understand this, we think we can help with our technology. Now, how can we assure that part? Of course, there's a challenge for us. We need to provide the technology, but those companies, what they need is to define what we call feasible KPIs, key performance indicators. We have these goals that are measured this way against those projects that are occurring on time. We call a roadmap. Some of them are IT, some of them not. And that leads also to how the organization digests this challenge. And organizations are human people. There is resistance, no? There is what is called OCM, change management, but you need a sponsor. And you need to understand that there are a mixture of different talents. There are old guys and young guys, and they need to work together. And that's positive because that's the reality. But you need to drive this with the technology as well.
Okay, thank you, Miquel. And talking about the different generations in a company and the change of mindset, could you Guillem, tell us which kind of dynamics are when it's made the change of mindset in the companies between these young guys or older guys, because they come from different generations with different preparations, but all of them have good skills for the digital transformation, for the change of mindset of a company. So if you can tell us.
Sure, Jaime. So let me maybe start with a short story about how this mindset, I believe, it's critical, right, to do this change in mindset. So when I joined the anti-fouling research platform, we wanted to study and understand from a fundamental point of view what are the parameters, right, that are affecting fouling and how we can prevent that and mitigate in reverse osmosis membranes. So when I joined that effort, I just found out that there was like literally millions of dollars being invested in kind of fundamental research that was leading probably to a dead path, right? So I start to challenge a little bit the industry state of the art, because where these efforts were being put is where the industry believed that was the source, right, of the problematic. But thinking a little bit, I realized that maybe that's not the right path. So what I decided is, let's start with this very small pilot, right, this one that you could do in the university, these biofouling simulators. Let's put my hypothesis and try to validate it. So that was probably done a couple of years, and in 2015, I just found out that there was an alternate path and was following it. So we just shift all these efforts and resources that we're putting in probably this more dead path to the development, and that's why last year in October, we were able to launch the new fouling-resistant seawater membrane. So, and I think that's a good example of this change of mindset that you need to have sometimes, right? Is challenging what it's belief in the industry, because maybe there's alternate ways, right? And maybe there's even room for creativity. And that's why I think it's that important having this link, right, between fundamental research, not going it forever, right? It needs to serve a purpose. It needs to be focused to solving a problem that our customers need to have, but it doesn't need to be like kind of just launching a new programmed, right, without validating anything. You need really to understand the fundamentals. And for me, this change in mindset is fundamental. And also the fact of collaborating between different functions. We, for example, myself and our team in Tarragona, we're very focused on application development, right, on testing how different membranes behave under real conditions. But you need to have a strong team, like the team that we have on the US, that really understands the fundamental of the membrane chemistry, the element construction, the fit spacer dynamics, and having this link, this continuous dialogue without any prejudices, right? With a fresh input and not being challenged, telling you, no, that doesn't make sense because that's not gonna work, right? Like giving you a chance, right? Let's try it, why not, right? I like this word of why not. And that's for me what deep tech means and what is set up for a success, this change in mindset.
Yeah, this is one of the things that humans can do and machines not. To connect different areas, to connect different ways of thought. Machines can connect data, but not ways of thought. So it's the best way. Okay, thank you. So, yeah, it's not. Yeah, okay. Would you like to make some questions, the audience? Okay. So, yes. Yeah.
Hi. Hello? Yes. My name is Errol Edwards from B6. I'd like to link back this to the keynote speech. When I went to school, we had something called the 3 R's. The 3 R's in school was reading, writing, and arithmetic. And I heard this morning about this aspect of, which we all recognize, an essential part of the climate change, of the reduce, renew, and reuse. What I'm not seeing, I think, is the industry recognizing what we need to do in terms of the reuse of water. We hear a lot about applied technology to water treatment and wastewater treatment, but where is the application of technology to recognizing the reality that we will not have water bodies to convey this water for further downstream reuse in the future? That's a reality. What are we doing about the reuse in these fast-growing urban centres? What are we doing about applied technology for aquifer recovery, aquifer storage and recovery? What are we doing about the reliable technologies that we have to persuade the communities this is safe water that can be reused? Europe is far behind, in my opinion, behind the Middle East, because mother of invention is necessity. And this is what's happening in the Middle East. But I don't really see Europe recognizing what's in front of them in not too many years in the future. So I'd ask that question of the panel.
Okay. Who wants to start? John or Dragan, for example?
I agree. Firstly, a couple of key points. Necessity being the mother of invention. Unfortunately, I think those of us in Europe are going to find necessity, increases in years to come. So one can hope, therefore, we get invention. Secondly, your point about us not leading the world in some areas. So, if you look at Singapore and the water recovery and water reuse levels there, it's in a completely different place to Europe. So, answering with a UK lens on this, I think it's a societal issue, not just a water company issue. So I look at the regulatory bodies that don't allow treated water to be put back in rivers, even though the water is cleaner than the water that's in the rivers you're putting it back into. We're not allowed to directly inject treated water back into aquifers. So the treated water on the south coast of the UK, which is the most drought-stressed part of the UK, is put out to sea, which is totally insane. We don't build houses that have multiple water systems, so we have no grey water reuse, and we're not putting the treated water back into the rivers further up, so it's then taken out. It's put further down, so it goes out to sea. So for me, there's a societal change in terms of our attitude as to what's acceptable, And that's partly in the regulatory bodies, it's partly in the general public, it's partly in those who look after the built environment, and then some of it's in this room.
Guillem wants to answer too. Sorry.
Yeah, I really like your question, and I just wanted to give kind of an alternate approach that we follow to address this question. So you can go for this direct wastewater reuse, or even injecting right upstream on a river. It might have it's probably more challenging, right, for the public to accept. But an alternate approach that we follow in Tarragona was a little bit different. So what we did is, for the Tarragona region, 100 kilometers south of Barcelona, that's a very drought area, like here, a little bit in Valencia. And we take water from a river called Ebro River, which is very stressed, right? So it's got a delta each year. As it's getting less water, less sediments, it's getting a little bit of regression, seawater intrusion. So we launched a project that was aiming to, instead of depurating the wastewater and sending it to the sea, we could treat with reverse osmosis membranes this water, and then we would be using this water for the cooling tower makeup water, for refrigerating the cooling water towers of the petrochemical complex, because at the end the industries are consuming a lot of water also. So what we did is reusing this water for refrigerating the cooling waters, and thanks to that, because the reverse osmosis water has better quality, we were not just freeing up river water for the population and for the river to grow, but because of reusing this water, we will, that was higher quality, we were able to decrease the freshwater consumption by 22%, and also the waste reduced by 50%. And we could do that because as the water has higher quality, we could increase the recirculation of this water from 4 cycles to 7 and even more.
Okay, we have no more time, but Miquel and Dragan answer the question in half minutes each one, because you want it, and we close the
Very
panel.
quickly. In Europe, there is quite a lot of recycling and reuse. If you look at the Danube, 11 countries, what they release in Vienna, they drink in Budapest. And so that was a bit light-hearted response. But there is, change in attitude of water companies. A few years ago, we started a research project with them called Water in the Circular Economy, WICE. And there were not many of them interested. Now everybody is jumping on that bandwagon. And in the Netherlands, everything that is residue from drinking water treatment is being reused now, 100%. So we're not talking about water itself, but from the water treatment. So there is lots of interest now in the water in the circular economy.
Miquel, you close.
Precisely linking with this initiative, I think that the area of the Netherlands and Belgium is very far ahead in these initiatives. There is a pilot quite mature in the city of Ghent that is an intelligent building, that all the water is fully recycled. That's in an area, in a shared location by the council, so it's together the university who does the research, the water company provides the facility, we provide IT, and the city of Ghent is getting those specifications of recycling water in the building in order to make a standard for the city construction, which is the next step. And they recycle the wastewater and they use the output of that for the gardens and the heat for a plant that is quite near, etc. So I think that's I work on global basis, and honestly speaking, I did not see other peers around the world so far ahead as they are doing in this area.
Okay, so thank you very much for your time and for your comments, and thank you to be here.
Ladies and gentlemen, we now have parallel sessions going on after this. So if you want to carry on with an investigation of digital twin technology that's taking place in the next room. And in here we have the group of distinguished leaders from the water sector who are going to be discussing the prospects for circular economy and digitalization. The panel is going to be led by Mohsen Mortada from Coal Engineering.